Hi guys, so today we're going to correct some exam questions, work through them I suppose really, and see what type of questions they're asking. As you know, we've been studying probability 1, we still have to move on to probability 2. So obviously most of the exam questions incorporate the second chapter, but there have been a few that have incorporated the first chapter. And the first exam question I'm looking at is 2012. Okay, so as we know, probability comes up in paper 2. So this was a long question, and A, B and C were to do with statistics, and then D was to do with probability. So it said a property is said to be in negative equity if a person owes more on their mortgage than the property's worth. A report about mortgaged properties in Ireland in December 2010 has the following information. Of the 475,136 properties examined, 414 of them were negative equity. So negative equity, it means if you are paying more on your house to the mortgage company than it's actually really worth. Of the ones in negative equity, 11644 were in arrears. So arrears is when you have not paid up, so you're a little bit in debt, so you've missed a few payments. There were 317,355 properties that were neither in arrears nor in negative equity. What is the probability that a property selected at random from all those examined will be in negative equity? So probability, you always start, it says give your answer to 2 decimal places, but I would always say you start by giving it as a fraction. So on the bottom of the fraction is you have the total. So we can see here that the total number of properties examined was 475,136. So on the bottom I have 475,136, and it says, what is the probability that the property selected at random will be in negative equity? So how many are in negative equity? 145,414. 145,414. And I type that into my calculator and I'm going to get 0.306, and it says to 2 decimal places, so I'm going to write it as 0.31. Okay. The next part of that question, what is the probability that a property selected at random from all those in negative equity will be in arrears? So all those in negative equity, so that's my total. So I have 145,414 on the bottom. And what is the probability that those selected will be in arrears? So how many are in arrears? 11644 is in arrears, and I type that into my calculator and I'm going to get 0.08007. It says to 2 decimal places, so it's 0.08. Okay, so I've just moved my part A part up here, the first part of it, and my second part to here, and I'm on to the third part of this question. So far, these are well in the paper. You've done a lot of maths before you get to this point, but very reasonable. Okay, find the probability that a property selected at random from all those in arrears will also be in negative equity. So what is this? This is conditional probability. So yesterday in our live lesson we were talking about what if this happens in relation to this. So here we have find the probability of a property selected at random from all those in arrears will also be in negative equity. Okay, so the probability that they are in arrears also in negative equity. Okay, so the probability of negative equity. So we know ourselves with conditional probability that it has a certain formula, and so we're going to focus on that formula now. So the question again is the probability that it is in negative arrears given that it has to be in arrears. Okay, so the probability that it's in negative arrears given that the probability that it's in arrears. So how we write that is it is the probability of negative equity union the probability of arrears all over the probability that it's in arrears. Okay, so I suppose how many are in arrears? How many are in negative equity? There's a huge amount of information here, and a really good way to do this is to visualize it. So I'm going to create just a little bit of a Venn diagram and kind of write the bits of information in it that we know. Okay, so I have two circles here. I'm going to call the first one negative equity and the second one arrears. We know that this is all of the properties in total. So the universe here is equal to 475136. Now, we're told some little piece of information as regards there were 317,353 properties that were neither in arrears or in negative equity. So they are actually going to go outside. So here I've got 317 and 355. Because remember, we're looking for this bit here, the bit in the middle, to go on top, and then we're looking for the bit in all of A to go on the bottom. And so when we do a diagram, it's going to make those numbers a lot easier. So we know 414 of them are in negative equity. So that doesn't mean negative equity only, that means negative equity. So we know that that whole circle there should add up to 145414. Of the ones in negative equity, 1164 were in arrears. So what they're actually doing there, they're actually telling us how many are in arrears. So I'm going to write that in there. So I'm going to write 11644 in here. So we've got 11644 in here. We know that from looking at this, the whole 145,414 of them were in negative equity. But of those ones, we know 1644 were here. So I'm going to subtract to get this amount here. Okay, so 145,414 minus 11,644 is going to give me 133,770. So these are the people that are negative equity only, 133770. Now, how am I going to find the people that are only in arrears? Because that information hasn't been told to me. Well, I do know that the whole of the universe has to equal 475,136. I know 317,355 of those mortgages were neither in arrears or negative equity, so they're outside. I know that 11,644 were in arrears and negative equity, and because I knew how many were in negative equity, I'm able to find out how many were just in negative equity here. So how am I going to find this out? Well, I'm just going to add these three together and subtract it from this, and that will tell me how many is just in arrears only. So by adding those three there, I get 462,769. Let's subtract it from the total. So 475,136 minus 462,769. Subtract them there, and I'm going to get 12,367. So that is the number that fits just in there. And now I have all of the information to do my formula for conditional, which is the union of the probability of being in negative equity and in arrears, which is 11644, all over the probability that you are just in arrears. So actually, I know that, that it's probability of A, isn't it? So it's the whole circle of A. So I actually need to add this with the 11644 just to make sure. And if I add those together, I get 24011, so 24,011. So 24,011 goes on the bottom, and when you put that in, you're going to get 0.4849. So to two decimal places, 0.48. So for me, the hardest thing with that question was the visualization, okay? I know you know the formula for conditional probability. We've just spent the last few days doing it, okay? So the probability that you're in negative equity and arrears, intersection arrears, that should be, all over the probability that you're in arrears. And when you see it in a Venn diagram, that becomes extremely easy, because you've obviously got your intersection bit here, and then the other bit is the bit that's all in A. All right, so I would do a little Venn diagram when you're dealing with lots of numbers like that to help it. Okay, the next question then came up in the 2011 paper, and it is, there are 16 girls and 8 boys in a class. Half of these 24 students study French. The probability that a randomly selected girl studies French is 1.5 times the probability that a randomly selected boy studies French. How many boys are there how many boys study French? So you're hearing here that the probability of something is the same as the probability of this. And what they're doing there is they're actually giving you an equation. Right? Okay. So an equation obviously is when we have an equals in it. So they want us to figure out something. They're telling us it's the same as this. We're thinking an equation. We got to do a little bit more work. There are 16 girls and 8 boys in a class. Half of these 24 students study French. Okay. So we need to, I suppose, get ourselves a little bit of an expression for what's actually going on here. So half of these 24 students study French. There are 16 boys and 8 girls in the class. What do we, I suppose, not know? We don't know how many boys there is in the class that study French. So let's let X equal boys who study French. Now, there are 24 students who study French altogether, so then we know how many of those are girls. Well, 12 would be half of the students. So if there's 12 students altogether that study French, and we know X is the boys, then 12 minus X would be the girls who study French. So now we have an expression for the boys who study French. We have an expression for the girls who study French. The probability that a randomly selected girl studies French. So if you are a randomly selected girl, the probability of it. So there are 16 girls altogether. The probability that you study French is 12 minus X. Yeah? So the total number over the actual total. So that's the probability of a randomly selected girl studying French is equal to 1.5 times the probability that a randomly selected boy studies French. Right, how many boys is there altogether in the probability? 8 boys. How many study French? X. And that is all the hard work done, because now we're just going to do a little bit of cleaning up and I suppose making sure that everything looks a little bit nice. You can do some algebra, you can multiply both sides, and you're going to get 96 minus 8x equals 24x. X is to one side, numbers to the other. 32x equals 96, and then we're going to have x equals 3. So the question was, how many boys study French? And that's what I started with. I said let x equal the boys who study French. We were told half of the 24 students study French, so then the girls who study French is 12 minus x, and that's what we needed, because in the probability we're told girl who studies French, so you needed those in the expressions. So a little bit of work there, a little bit of probability, but mostly I suppose reading the questions super carefully.